the next speaker, and I want to say I'm sorry for breaking during our conference, and go to the Professor Jafarov from Baku State University. You are welcome. Can you begin your...
Okay.
I would like to discuss some properties about the number generalizing model and analog next leading order contribution to quark mass in Pion sector and some other properties. Okay, which related with regularization procedure in number generalizing models. Okay. Next. The report is organized as follows. In first section, we describe the method of construction of midfield expansion with the fermion bilocal. Okay. So for the number generalizing model with SU2 vector axial symmetric for quark interaction, and for the sake of completeness, consider the well-known leading approximation result of this model. In section 2, in comparison to discuss the calculation in dimensionally analytical regularization and four-dimensional cutoff regularization span, we show that four-dimensional cutoff, the meson contributions can destabilize the NGL model. In section 3, the analog correction to quark mass, which in Pion amplitude sector gives us the symmetrical result. The corrections in both regularization in four-dimensional and dimensional regularization equal strongly to 0. Next. The Lagrangian is the usual form. Schwinger-Dyson equation also is the usual form. Next. Genetic functional has also the usual forms. Okay. First, general leading, general order functional, genetic functional has the form which gives us the following equation. Next. The leading approximation generates the linear iteration span. Consists in a step-by-step solution of the equations as the form of Schwinger-Dyson equations. Okay, next. Functional Gn has the form where Pn is the polynomial of 2n degree on the bilocal source. The unit connected green function of the leading approximation is the quark propagator, where m is dynamical quark mass, which is a solution of the Gauss equation of the NGL model in the chiral limit. Okay, next. The first iteration step contains the leading order equation for the two-particle quark function, where k is the kernel of this integral equation. The graphical form for this two-particle function for the amplitude has following form, which includes only the propagator of the quark. And first order quark function equation has the following graphical form, which in homogeneous term contain two quark main leading order function. Okay, next. Since the number generalizing model is the midfield approximation includes quark loops, the essential aspect of application of this model is the regularization. Most common regularization in number generalizing model traditionally entail a four-dimensional cutoff in Euclidean momenta or three-dimensional momentum cutoff. Other regularization, Pauli-Villers regularization, and non-local Gauss form factors also use it in number generalizing model. The least common regularization for NGL model was a dimensional regularization. Okay, next. But next, it should be stressed that the treatment of dimensional regularization, the regularization parameter is not all of deviation in the physical dimension of space. In best report by Professor Tomohiro Inagaki in conference celebrated the 70th anniversary of Georgian National Academy of Sciences in 2011 year, and also the collaboration with Professor Alexander Kvinikhidze and other scientists about the characteristic features of the number-ional linear type 4 fermion interaction model in the dimensional regularization has been in detail enough discussed. Okay, next. However, okay, next. The model parameters in our approximation in leading order, chiral condensate, Quark mass regularization parameter C, and dimensionless Kaufman K has the following form. Okay, next. It is, but in 4-dimensional cutoff regularization also were calculated the model parameters. As it's seen from these tables, the value of the main parameter, quark mass M, in the model with 4-dimensional cutoff is much more sensitive to the value of the chiral condensate in comparison with that of the model of dimensionally analytical regularization. Okay, next. First order equation of mean field expansion define correction to quark propagator. This equation has the form. Next. Okay. We'll discuss it, all solution of this equation in Russian Journal of Physics in my previous works. Please, next. Science. This calculation, numerical calculation, gives us since a Pion correction to quark mass in both studies, that in both regularization equals 0, this value are full correction to quark mass. Regularization and 4-dimensional cutoff regularization. Okay, next. Okay. Here, using the leading singularity approximation, we have the following ratio for the quark mass in next expression according to this expression. The Pion contribution in quark mass is equal 0 according to this formula and this formula. Okay. In both regularization, it is properties of the our approximation. Next. In my opinion, this result related with result which by academician Alberto Felice and all in this book, which it is more likely connected, recurrent imposing that all mass correction to the sum were equal to 0. It is indemnification follows from invariance of transformation Carsemic gamma 5 group transformations. Okay, next. It is originally investigated. Okay, next. The condensate and the quark mass correction allow us to specify parameter of SU2 in GL model. We modify formula for condensate as follows. The formula Phi stays the same size correction to amplitude generated in the next order of mean field expansion. The quark mass is the mass. Following values of model parameters for this improved choice are given in tables 3 and 4. Please, from Russian Journal of Physics. In dimensional regularization, is it period? Next. For dimensional analytical regularization, we can estimate all parameters for physical values for condensate but next. There is very important moment. For dimensional cutoff, the meson contribution can destabilize the number ionization model. Okay, note that increasing a number of flowers is at UN F number ionization model, the situation takes a turn for the worse because a main pseudoscalar contribution is proportional to NF. As that, for dimensional analytical regularization, the situation is principally different due to the coincidence of sign of meson contribution with the sign of leading contribution in condensate. For this regularization and stabilization of the model take place. It is clearly seen values for regularization parameter C increase in comparison with the corresponding leader order values. Is a shift to a region of stability of model where this meson contributions decrease. The original result was published in Russian Journal of Physics, my earlier works. Okay, next. Thank you
very much for your very interesting talk. And I want to ask, we have some questions from online. Please. Just we don't hear you. Could you repeat, s'il vous plaît? Repeat your questions, please.
Yes. You evaluate the stability of the loop expansion in NZL model using the four-dimensional cutoff regularization.
Yes, okay. It is four-dimensional version, but the originally works.
Yes. My question, it is the stability is a property only for observed in four-dimensional cutoff regularization. I mean, three-dimensional cutoff regularization, such kind of stability cannot be observed.
I would like to discuss this question in detail for you after the session in my email. Moment. Okay. Thank you, Tomo, for your question.
Okay, thank you all for being part of our conference. And I want to say sorry for our not planned breaking our conference is connected with technical problems. And I want to close our sessions today and hope we meet next year in this conference. I want to say thank you and to all. Bye-bye. See you later.
See you in Baku.
See you.
Next meeting.
Okay.
Next meeting.
Also. Thank you very much.
Thank you very much.
Bye-bye.
Bye-bye.